If you need spouses, anything, you please tell them in the entry there, in the table there. Another thing is that on Sunday we have a bus tour with the new port. The old port area had been renewed for the Olympic. No, many of you already had inscribed. You could do that by the internet. And then after there will be 2 p.m. there will be a lunch in the restaurant that will be near this old port area. And so you're invited to do that online, so you have to prepare yourself with a number of buses and so forth. And then please do it. And for the lunch also, 2 p.m. lunch. If you want to go direct to the lunch, there is the address there. Anyhow, so I want not take your time, so I pass to Pablo.
Very nice to be here with you. Aloysio invited me to give some classes when I came back from Chicago in 79, 80, 78, 79. And the reason he probably invited me to give some classes here at IMPA in growth theory and general equilibrium macro models, the reason is probably he had a good smell for the future. So it was that man, the reason. So how to transmit the knowledge that we are getting there to Brazil. I was at Chicago when the revolution came. I don't think that the Nobel Prize should be given every year to economics. At least at the time I was there, I had a sense for who are the few men who really changed the profession forever and put our level of knowledge in higher grounds. And this man is one of them, a few of them. They are very few indeed. So I was there. Everything was moving around him. Friedman was still there. It was his last year there. A man of great content, fighting against the Keynesians, macroeconomic theory being redefined. But then there came a tsunami, an entirely different level. General equilibrium, dynamic stochastic models, optimal control, dynamic optimization, Bellman's principles, the government, game theory. So the government was a dominant player issuing trajectories of fiscal and monetary policy, rational agents reacting not to policy, but to policy rules, and they acted, and they understand, and they changed the structure of the models. So it was a really incredible revolution. Everything was changing. And everybody around this man, Robert Barrow, a physician, so latecomer, trying to catch him, couldn't. Thomas Sargent, trying to get it right, great guy, helped a lot, contributed a lot. But this man, quite ahead and changing everything. So it's a pleasure to have him here and to satisfy him just these 3 minutes because he is the man.
Thank you very much. Well, thanks very much for the nice introduction. It's great to see you again after all these years. Do I need this?
Yes. No, there is another option.
I got stuff. Okay. Well, all right. Well, it's a pleasure to be here for 2 reasons. One is to celebrate Aloysio Araujo and his career, which is not really ending at 70, at least I hope, but he's always doing something interesting, and I think of him as being in sort of his prime. So I'm not going to be able to, I guess we're going to spend most of the summer celebrating Aloysio, but I'm not going to be here for all of it, so I want to make sure I said this this afternoon. The other thing I got by surprise is to give the David Cass lecture. And David was a colleague of mine at Carnegie Tech, and a friend of mine before and after. And just think of people in my generation. We were at the same generation. I think I learned more from Dave than from anybody else I knew. So now it's true that, so I'm glad to be giving the David Cass lecture, and I take it as a real honor. Okay, so I'm going to be talking about the Industrial Revolution, and I'll tell you what I mean by it, and so this is something I've been looking at and trying to make sense out of. What are the underlying forces? What is the Industrial Revolution, and what are the underlying forces that brought it into existence? Written a lot, and I felt I never quite got it. Now maybe I didn't get it in the paper I'm going to give here either, but I'll be moving in directions that I hope are productive. I've got more slides than I have time, so I'm going to skip over things, but at least you'll see the equations flash by, and if we have enough time at the end, I can go back to any one of them and fill out the gaps. Here's a nice 1966 statement about the Industrial Revolution, and it doesn't depend on iron and coal. It just observes the fact that until the 19th or mid-18th century, no society had undergone sustained growth in income of the average, of ordinary working people. I'm not talking about the pharaohs and the kings and the queens. I'm talking about the people who actually do the work. And the level of such people over history has been pretty much stagnant as far as we can estimate it until really quite recently. And this has been, so I think of sustained growth is the factor that I think defines the Industrial Revolution. And when you look at it that way, it's still going on because there are a lot of countries that are far behind the leading countries in terms of income of ordinary people. So how did it happen? After centuries of basically subsistence income for working people, you move into a situation of 1 or 2 percentage point growth in income per person year in and year out. Not stable, not constant, but so how did it happen? And one of the things that has to happen, there's been plenty of progress in technology and in human population. Many important advances came well before the 18th century. You could think about them as well as I can. Why didn't it happen then? And this is the question that instead what did happen is that as more knowledge was gained, people used it to expand. If you discover new land, new techniques, people used it to expand the population. Basically, families chose to hire more kids, have more children, and the level of income per person remained the same. So if that's true, why isn't it true now, or why wasn't it true in the 19th century? So that's kind of the question we're looking at. I want us to look at. And I want to look at 2 sets of data. I'm not going to do a lot of data here, and I'm not going to give you any calibrations or anything, but I want to look at some evidence that, to me, has to be accounted for to get anywhere on this subject. So each one of these dots is a country. It's taken from the World Development Report, and it's, I'm sorry, I keep, for 1980, and you can go through any, you get a picture like this for 81, 82, 83, 70, I'm just picking one sort of out of the hat. I got the log of per capita income on the horizontal axis. That's going to be from Angus Madison's data. And the fraction of employment engaged in agriculture, I get from the World Bank. And you can see this just very clear downward pattern. And like I say, if you move up to say 1990, all these dots are going to be sliding down this hill and get to the bottom, which is where all the wealthy countries are. But it happens over time. I wanted some time series too, so I got, this is from Kuznets' study, augmented for recent years by me. And here he just plotted, he just looks at the unemployment share in agriculture for countries across time. And there's quite a lot of them, but I picked UK, US, Japan, and India, just for variety, and I don't know. Now I wanted to match that up to the other stuff, so instead of calendar time on that axis, I transformed it into log per capita GDP, which is what I did for the cross sections, and then we get the picture looks just like this, same data. I just changed the horizontal axis, and I had a curve fit to these things. This is fit. There's just a fitted curve. It's nothing deep here. That's the curve that I think fits the cross sections pretty well. Exact same curve as it here. So we go back and forth between, I'm sorry. I lost my, there's no difference. I mean, the same figure picks up both time series and cross sections. And the calendar time just doesn't belong in the, it doesn't belong here. So I want to keep that correlation between agriculture and income in mind. Now, what's this traditional? The really poor countries, the ones with a high fraction of agriculture, are really poor. They're countries that are doing the same kind of farming that their great-grandparents did, with the same tools and the same knowledge. And the low countries down the bottom, like the U.S. and Canada and Brazil, they don't have a high fraction in agriculture. They just have modern technologies. All right, that's one feature I want to look at. It's kind of people used to call it dual economy. Now I want to talk about another fact, which is going to come up in connection with Malthusian theory. We want to look at how people decide between producing more per person or having more persons. And I'm going to get back to that. And what's happened in the successful economies is the UK, this is all Madison's data, is for a long time both the red curve, which is population, and the blue curve, which is GDP, total GDP, they move pretty closely, and we don't get too much. We're not going to get too much. What we know in 1500 or 1600 is not. Let's not argue about that. I call those equal. And then you can see in the GDP growth started pulling ahead quite early for, you'll see, for UK, And it really took off in about middle of the 19th century. I'll just go quickly through some other countries, some other rich ones. France, which you can't even see a wrinkle in the rate of growth of production. United States, hugely, the huge amount of immigration flowing in from elsewhere in the United States. But still, the relative growth is the same as in the UK's. Japan, which got going as a capitalist economy in 1870, and then some recent countries. Mexico, you can see no real expansion in income per capita up through 1940, and then you see a little bit of action between 40 and 60, and then things started to take off. So the recent look at Nigeria. Again, they're not even on the map in a way until 1950, basically a British colony, and they had huge growth, but it's entirely taken up by population growth, and the demographic transition it just hasn't happened there yet. So that's kind of a range of data. So these things happened, where they do because people are making, individual people and families are making decisions. And the outcome of those decisions is the numbers you see on the screen. So to understand this, we want to talk about what are the key decisions that people are making that bring these things about, and why do they make them? And I'm going to take the pristine view that the people and their utility functions, if you like, are the same from any place, any time. So we won't have any ethnic or it's just they won't play a role. Maybe they should, but they're not going to in this paper. And I want to first think about the demographic transition. People seem to have a choice between when something happens to increase their wealth, they could expand their families and support a larger family, or they could bequeath to their children, give them a better start in life, rather than just have more of them. Now, Gary Becker started thinking about these issues back in 1960, and he wasn't thinking about economic growth at that point, but he said there's got to be two elements of childhood in order for this to happen. And people like their children, and so it's a good, as an economist would say, to have more kids. You have more money, you buy more of the things you like, and that would include having a larger family. But that doesn't fit the facts that we've been looking at entirely. So the other idea is we like our children to be, well, each of them, we like them to leave them with as well a start on life as we can do it. So Gary called that the quantity-quality trade-off. You want to have a small number of well-launched children, or a larger number, and let them go for themselves. Now, I think that this logic of the quantity-quality trade-off is really essential to talk about the Industrial Revolution. So I want to talk about it. There's a lot of other work that's been built on that, including Becker in contact with Robert Barrow and Kevin Murphy, Robert Tamura. In later work, he's focused very much on on growth. And some similar results by others, including me. And I want to follow up on that. So here's the plan. I want to start out with a simple model. All these models are going to be stripped down because if I get too complicated, I'll lose the thread. I want to write down a classic Malthusian model with a Bellman equation, but otherwise something that would be totally familiar to Malthus, Ricardo, Adam Smith. Now that was a good theory. It didn't take us through the 19th century, but it's a good place to start. Then I want to talk about a human capital good model, and I'm going to take these both as though they were completely standalone places with no interaction at first. So we got this farm models for Malthusian life, and then we got some human capital guys who just produce goods out of their brain power. You might think of them as rural and urban. That's how I do. So I want to get these models worked out. They're both kind of different because they have to be different. And then I want to do something which happens in reality. I want to merge the two economies and let people move around so I can choose whether I want to stay on the farm or move into the city and take my chances there. And now that, there's just too many possibilities, so I'm going to give you two extreme possibilities. And that's what I call migration 1 and migration 2. And they'll be pretty simple. And then I'll have a conclusion. I wonder, okay. So, now what I'm going to do here, I'm just not going to work out a bunch of Bellman equations, but I'm going to put them up. I'm going to put them up on the screen, and then I'll tell you what. And it takes me a long time to work this stuff out, and I'm not going to do it in public, and it'll take up all my time. So here's the Bellman equation of a typical family, and this is the family. You're never going to see any other family in this talk. I'm just saying. And this particular family owns some land, and at the start of a period. A period now is a generation in this little model. So I look at a family that has X amount of land, and look at the bottom of the screen. If he uses that, he can produce AX to the alpha, because he's got his labor plus the land. That's what he can produce. And then he's going to produce, what's he going to do with that production? Well, he's got to raise his kids, he's got to feed himself and the kids. That's what that K for. You could be skimpy on the kids end, or you could be lavish, but that's just a fixed number that I take to have just for having children at all. And then you can have a question of leaving behind your farm when you go and your kids take over. Now you could have lots of kids and leave them all small farms, or you could have restricted number of children and have them get a pretty good. And I'm assuming that V of X is the utility of the guy we're talking about, this first parent, and then he treats this. He assumes that his children will have the same V of whatever they have, so they're like himself. But if he's going to have lots of kids, and he's going to have to divide the farm up into n pieces. So that's the situation. So B is going to be kind of how much does he care for the kids, how much quality is he looking for? Beta is. And eta is how much does he just like to have the pitter-patter of little feet? You know, how much does he get pleasure out of his children? Okay, so you can solve that Bellman equation and find out what's the optimal number of children. N is, like n equal 1 is replicating yourself, n equal 2 is you have 2, and so on. I'm not going to get into gender stuff here, but, you know, I don't think you need my help on that issue. And you can also, it's also interesting, I think, to think about, sometimes you have agrarian economy is just a bunch of individual farmers, but sometimes it's, you know, one big farmer and a bunch of landless people, like Egypt. So we can also calculate the, you know, they have different options and different behavior in. I'll use both later on. Okay, now what if we have a whole economy of people like this? So we start out with n people in the economy, capital N, and they all have little n. Then next period, the economy as a whole will be big NT times little mt. That'll be NT plus 1. So, you know, these decisions to make about childbearing is what determines the population growth in this economy. You can write out the population dynamics just in terms of capital N's. And this thing is not going crazy here. It's going to converge to a steady state. And this is just what Malthus is like. A lot of people attribute Malthus to some truly crazy claims, but this is just exactly, this is just a standard dynamics, and it works for rabbits and squirrels and human beings. You know, the whole crowd will all settle down. And what determines it is really this what you think is a reasonable level to have for children. If you can't afford to keep them at some decent level, you're just going to have to cut back on the childbearing. So that's what this is. And this has been an extremely successful empirical model, and the test for me would be how come people in the very rich farming countries of the world, like South China or parts of Indonesia, have about the same standard of living as people who are up in the edge of the Arctic Sea or live in the middle of the Sahara Desert or something like that. And the answer is because they're all working on the same, they all have the same utility function, but they have different farms to work for. I mean, that's the world that Adam Smith and David Ricardo grew up in. They were Malthusians. Nobody had ever seen sustained growth of an economy as a whole. All right, that's it for that economy. I want to switch to a human capital economy. And here, I've got a kind of fancy way of thinking about it, but I want to try and strip it down as much as I can. What was the Industrial Revolution? I don't want to say, you could say it's an increase in the rate of technical change, but that's just a label for what we see, and it's individual decisions that actually, you know, do something that expands the level of human knowledge, and it's a whole lot of people are involved in that in any society, except I'm going to take the assumption here, which is not quite right, but that it's all educated, liberal people, people who live in cities. Those are all the guys who generate new knowledge in my model. And who are we thinking of here in reality? Well, I'm thinking of scientists for sure. But scientists are a very, very small, I'm not even sure when they first existed as a identifiable unit, but I'm thinking of people who live by their wits, live by their intelligence and their knowledge. So terms like bourgeoisie, intelligentsia, traders, merchants, middlemen, those are the people I'm thinking about. Throughout this, when I work out this model, I'm thinking about an economy that contains nothing but people like that. Landis, Mulcair, Greif, Botticini, and Eckstein have a really interesting book on the, and Deirdre McCluskey has a new book out. All of them trying to look at who are the individual people or individual types that matter to make this growth, to make this miracle of sustained growth take off. We've always had growth in production, but when did it turn out to be growth in living standards of ordinary people? That's the puzzle. So my human capital guys are gonna give us this. Maybe it's the right way, or maybe it's the wrong way, but that's what I got to deliver. So I'm going to think of a distribution, a CDF of people with different productivity levels. They're just born in there, and so at any point in time, you just average all these people. There's no capital around here. There's no trade. So we'll just take the sum of, or the integral of average, the total of all those people. I guess this is per capita GDP. Now these people are going to have because they're people. They're going to have they're going to have to be born and do something and die or retire. And I'm just going to take that demography as a fixed thing and constant. So as soon as, for all the people who are dying, there's an equal number of people getting born. So, and I'm going to, so I'm going to let this G be the CDF of the people of age S. That's going to evolve over time because I'm going to have, these guys are going to be in a growing economy, but I haven't told you how that growth occurs yet. And they're going to meet people at some rate, alpha of S. Now, alpha is just the number of meetings per unit time, and I'm going to have that be an increasing function of schooling, but that's in a minute. But what are these meetings are? You bump into somebody or read a book by somebody or whatever. You make contact with some other person, and if that person's got a higher Z prime than your Z, you switch from your Z to his Z. So you know where to go but up, because when you meet a bad match, you ignore it. When you get a good match, you exploit it. And that's the whole theory of knowledge growth that I'm going to talk about. It's easy to see ways one might want to spell it out, but not here. All right, so now I'm going to have a, this is one of the things I'm going to have to skip on. but there's a equilibrium problem that has to be solved. First, I'm going to talk about balanced growth path models, just because that's the only way I know how to get through all this stuff yet. I mean, at least in paper and pencil, so my growth depends on how hard I work, how much to meet people, my alpha S. Bigger that is, that's my contribution. And then what that gets me is contact with people out there who, a lot of whom are a lot smarter than I am, or know stuff that I should know and don't know. And that's the other side that there's kind of two sides to this thing. In an equilibrium, they have to work out. It would take me a long time to spell this out, but I end up arriving at that table there. This economy, I'm going to assume this economy is growing at some level gamma. And it's going to be a constant level gamma because I'm restricting myself to balanced growth paths. Okay, so then I take this gamma, and it's got to work out for both. I can solve for gamma. Gamma is the thing that I don't want to. How fast is this economy going to grow? That's something I want to find out. And that's what this math is supposed to deliver for me. Now, these guys are Fauché distributions, and theta is the number of good ideas out there, the fatness of the tail of some Pareto tail. I'm looking at it here. So theta is a given that determines how fruitful it is to learn from other people, and alpha is how hard or skillful you are at tapping it from other people. And that ends up in an equation that I've written there, and everything is given except for gamma. And I got one equation. You know, I got an equation for gamma. And let's have a look. Let me come back. You can just look at the equation and see that if gamma is equal to 0, then that solves the problem. And you can also see that the right-hand side is going to be an increasing and concave function of gamma. So put those two together, and you might get this concave thing is going to have to pass through 0. And then where else is it going? That's, well, in the red curve, which involves people who are fast at, who are searching a lot, and if people have it also matters if they're long-lived people, because this is going to be a world where the people get, knowledge keeps growing throughout their career, okay? And the way you get growth is basically the new guys come in, and there are some old guys with some really good ideas out there that they can tap into. You start shrinking that, you lose the benefit. I mean, you got depreciation of ideas. That's what we're talking about here, and we all know that's a feature. So you want sustained growth, which depends something on schooling and longevity, and it's limited by So why am I interested in this little model? I mean, first of all, it's primitive, but it focuses on the social character of work and creativity. People don't go up on the mountain and invent stuff or write good music or you know, do anything that anyone cares about, except, so everyone, you know, you learn more in a society of people if everybody's identical, that just shrinks that theta to 0. Then you learn nothing because the guys you bump into are just replicas of yourself. So you want variety. The way I'm going to set up the problem, schooling, I think this is kind of cool, although I've never seen it really tested. That schooling is what's schooling do for you? When you graduate from school, you really don't know how to do anything. That's my personal experience. But they get, the schooling gives you access to conversations with educated people, and little by little, if you work with them and if you're in the right environment, then you learn, and those then the real. So I think the real earning comes about from on-the-job growth. There's nothing specific to this. This does not guarantee you solid growth. I said we can solve gamma. Maybe it's 0, maybe it's something positive. It'll be the bigger of those two. So, so the model fits stagnation and it fits constant growth equally. Now I think of this because you're going to be at some point where people are indifferent between these two. It's just what Cass and Shell. I really thought it was so cool that I'm giving them the Cass lecture, and here's one of Cass's most exciting paper. It took me years to appreciate what those guys had of sunspot equilibrium. That's what this is, isn't it? That would be. So you get a situation where if everybody wants to put their kids through school, I wanted my kids to do it too. And if nobody is, then, you know, my kids, if I give him to school, he's not going to have anybody to talk to anyway. So why bother? So it's this thing where you can both. Now I think this is good because no one really knows. Has Eddie come up with anything about why this particular timing of the Industrial Revolution occurred, and why in England, you know? So I think that's what Cass and Shell are telling us here is, don't try too hard to get a unique answer to that question. It may not be there. Okay. So I've given you two models, one of kind of a bourgeois economy and one of a farm economy. They don't quite match up together. The math doesn't, because in the problem I just said, we're looking at somebody through an entire career, and in the model of, well, it's a question of whether the unit of account is a year or whether it's a generation. So I have to pay some time fixing that up, and let me not do that here. But when I get it done, I'm going to have a Bellman equation. There was no Bellman equation in this model I just gave you. I've only given one. The only Bellman equation I'm showing you is a Malthusian one, but I want to get one for the bourgeoisie. Okay, and I wanted to have the same tastes as the farmers. So that's what we got on the top line there. You've seen it before. You've got to choose between his personal consumption, C, and the number of children he has, N. And then in my case, he's also going to choose the level of schooling. And that'll be a choice too, but let's just take that much as fixed. Not for the paper, but just for discussion here. And I'm also going to do, and this is something I take from a paper by Becker, Murphy, and Tamura, which is another paper on the same general theme, in 1990. Instead of sacrificing goods for your children, which is what the people in Section 1 do, I want to sacrifice time for your children. So here's the situation that a family's got to decide on the quality Z that he bequeaths to each child, as well as the number of children. Those are his two choices. Now, if he gets N children, then he's got he gets pleasure. Gets a certain amount of pleasure out of that. We've solved for that. And then he's also trying to leave a legacy Z to some of his children. I'll call that Z, and I'm going to have that E to the gamma because these guys are moving along a balanced growth path where, without my doing anything, my kids are going to have a better life than I did. And that's this E to the epsilon there. And then how much do I care about this? Again, that's raised to the power beta, which is by sort of how much I love kids, or how much I care about my kids' quality. So the top line is in some sense familiar, except the thing that you're passing on is an education, and not your farm. Then it's going to be subject to something. Now, I'm going to take. I've worked out in a previous section the optimum, under certain circumstances, amount of, given that you're going to raise a child, what's the optimum level? That'll give you a certain Z value. And so as a parent, you were born with beta, alpha, Z to the theta, E to the minus RS, and it was your parents who left you with that, and now it's yours. And then you can just consume all that, or you can put some kids through school. Well, if you have N kids and you give each one of them Z schooling level, and there's a delta Z, which is how much effort it takes to make this stuff happen, then your Bellman equation, that second line is right there. You can see the choice that's being made. Now, it's quite a bit different because in this model, I can decide how much of an education to give to my kids, but how much that pays off depends on the kind of society you're living in. So if you're living on the farm or in some backward country, and you put your kid through you know, it may be nothing he can do with it. So I think that's a big deal in these models is always what's the payoff in these human capital? What's the payoff from the education? I think it's been handled rather poorly in the existing literature, but it's certainly all right. All right, now I'm going to have to just there's no settling down here. This economy doesn't have. There's no fixed stuff like farm, like land, to limit the amount of population. So if I start running Malthusian stuff on here, there's not going to be a convergence to any particular number because you're generating your own wealth. So you work out the consequences. The n can be a bunch of stuff, but it could be bigger than one. You could be declining or growing in your population, which I think is kind of what you can see. You can certainly see it in Nigeria in one direction, and you can see it in places like Japan, which in another direction. All right. What have I got to do to put these two things together? Now this is going to involve, we're going to have to involve a law of motion. We're going to start out with a number of families in this human capital world. I call that NC for country, for city, and NFT is the rural population. And then they're all going to decide stuff, including how much to grow in the case of the C's, but also how much to produce in the way of children. Now I set up the city guys so they never want to change. If they want to just maintain themselves, they'll do this, then so will the next generation and so on. There's no links. I'm going to have to be less people are going to move, and it's going to be the poor people moving to the cities. How is that going to work? Well, that all depends on what's in it for me when I get to the city. And I haven't really spelled that out too much. Now, one extreme is you never get schooling, you never learn anything, but you're a servant for the wealthy. Think of the people from Pakistan going to the Emirates or something like that. You know, you know you're never going to get a chunk of that wealth that a few people in the Emirates have. That's just not the way things work. But you might get a better life there than you would staying in Pakistan. That kind of migration is one that I discussed here. You get a situation where people who migrate can get. There's a demand on the part of the city group for services. These guys can fill those services, and so it goes. Now these city guys are growing across the path, so this demand for services is going to get bigger and bigger over time because it's just a constant returns utility function on the part of the demanders, and that means that more and more people from badly educated people are going to be going into city services and reducing their work in the farm. So farm incomes are going to have to be rising over time because the farmers are getting shrunk down. Now, what's going to happen on the So that's all we need to do to generate this emptying out of traditional agriculture that I started the paper with. But these illiterate people, uneducated people, are still Malthusians when they get to the city. So, and they're getting paid more and more. And we've already seen the Malthusian thing. They're going to have more and more kids. So you're going to get an explosion of people, and if you just follow that out, here, they're going to grow without bound. So it's, like he said, like a proletariat blindly multiplying itself towards subsistence income levels. I mean, that's what they're doing. They're Malthusian. They're trying to reach down to that Malthusian level, but they get richer and richer. They can't do it. So all they can do is pump out the babies. Okay, so that's an extreme model. I think you can see parts of it, maybe even in this fair city. People are coming in with pretty much no education from other parts, living in the city and trying to hustle a living in that way. But it doesn't go on forever, does it? It's not going to go on forever. And in some places, it doesn't go on that way at all. So, so the second model, what you got to do is you got to have some kind of transition between the. If I send my kids to the to the city, can I also send put them in school? Can I pay I've got some sort of fees to be paid. So why don't we let people do that? So what do I do in the last part of the paper? You're a migrant into the city. You get two choices. You can come in as you are, produce kids same as you are, and let it go. That's the first model I gave you. Or you can pony up enough of your own to finance one child to go in to get an education. To keep things simple, I want all the people in that group, the educated group, to be identical. So I have to rig. Of course, that's not at all what would happen. But I just want to keep it down to two types, rather than have the number of types multiplying as I go, which is what I think really happens. So, but anyway, I rig it so that you can choose between those two. Now, remember, the poor here, maybe they're just too poor to put their kids through school, but they're getting richer and richer compared to what they were before this whole thing started. So it doesn't seem impossible for that to happen. And the way I've set it up, everybody's identical, these poor people, so they have to be indifferent between. They got two choices if they go to the city. They could also stay on the farm. So three choices. And that fact that they're indifferent lets me work out the full dynamics of this economy. And that's what's done in the last part of this paper. It's really quite different from the first part because we're looking at the numbers of certain types rather than the choices of people given types. You need both to get a model like this to work. Now, in fact, these two extreme things, you can mix them and match them any way you like. And it seems to me if you look around the world, you can see the South Koreas were pretty much agricultural economy, you know, in 1950, and and the bourgeois economy totally now, and they just did it. And then you get other countries where this lower class retains its position forever. So what do we got? We used to think about the revolution as coal and steel and sweatshops and stuff like that. And, you know, we can see that around the world here and there, no question. But the main, the sort of positive or constructive part of all this is in moving. Marx and Engels talked about the capitalists have removed, you know, millions of people from the idiocy of farm life or something like that. I mean, there's something to it. The kind of rural traditional agriculture is not a place that gives people options and in the sense that it does in city living, if the city living is in the right way. So the Industrial Revolution is still going on. It's got to finish until, I think, all those illiterate farm workers are gradually going to evolve out and into the world that the rest of us live in. Now, there's more of them than there is us right now, but the balance is changing every year, and all in the direction that I've described. And I think, well, there's more to be said, but let me stop here and save some time for questions.
I just shut it. So I've just been wondering about, there's been obviously an increase in inequality in